Hey, what's up, amazing hackers? I hope you're all doing well today. So, today we're going to talk a little bit about the PortSwigger labs. Now, I don't know why this image is in here, but it's not supposed to be. There we go. And it's gone. Now, we're going to talk a little bit about the PortSwigger labs because I really like these PortSwigger labs. Of course, I like them. They are gone. Now, we're going to talk a little bit about PortSwigger labs because I really like these PortSwigger labs. Of course, I like them. They are gone. Now, we're going to talk a little. There we go. My own voice is gone. Now we're going to talk about the PortSwigger labs. So amazing hackers, are you ready? We're going to go through as many as we can. Let's get right into them, shall we? Now the first thing that I want to show you is of course the first PortSwigger labs, which are very basic. Reflected cross-site scripting into the HTML context with nothing encoded into it. So all very basic, all very decent. So let's get right into it. The solution is very simple. If we access these labs, I also have my PortSwigger burp suite open, of course. That's going to be important for later on. But for now, we're just going to load these labs and I'm going to see if I have my proxy on. I did, but my proxy is not on here. So while that lab is starting up, it always takes a while. We're already going to look into the second one and we're already going to start this up for later. Now let's get back to the first one and let's look into the solution, because the solution is very basic. All you have to do is call an alert and it's going to be just a script into the input box. So you have here a search box, it's basic reflected cross-site scripting. So your script tag is going to work. If you start going to, there you go, script alert. If we're just going to pop an alert like this, that's also going to work very easily. What we can do is we can search for an image, source equals x on an event handler. So it's all very basic, as you see. There is nothing really special to this lab. Let's move on to the next one. In the next one, let's see. Let's go back to lab description real quick. Reflected cross-site scripting into the HTML context with modes, tags, and attributes blocked. Now this one is a little bit more interesting in my opinion, because if we go look at the solution, this all looks pretty big, but we're just going to go through it and see what happens. So we're going to go with our basic payload again. We're just going to go image first equals x, but they say tag is not allowed. So it's good that they say tag is not allowed. Hello amazing hackers, hope you're all doing well today. Thanks for tuning in. So they say that in this case the tag is not allowed, which might be interesting because then we can just try to brute force it. Now you might be wondering, how are we going to do that? I'm going to go into my HTTP history here. Oh, my proxy is not on, that's not good of course. Let's do that first. Let's set up my proxy properly so that all my traffic is getting proxied through a burp, and of course I'm going to set it up in PwnFox as well. We might need it later. Now let's repeat our request and we see it in here. We're going to send this to the intruder. Now why the intruder, you might ask, because it tells me that this specific tag is blocked. So we're going to try different tags in here. As the image is blocked, let's clear the selection. Let's select this as a tag. And now the PortSwigger labs, the PortSwigger XSS sheet allows us to easily copy all of the tags that we have available in HTML, and then we can just paste them. So we can just copy the tags to the clipboard and then we can go into our payload and here we can paste those specific tags. Now if we start our tag, we're going to notice that a lot of them are going to return status code 400, which means that they're blocked. Now if I go filter on status code, you will see that not much changed. Maybe length. Here you do see that something has changed. So here you do see that the length has changed on 2 of these tags. So we can do a custom tag or we can do the body tag. Both of those will work in this situation, but we still get a 400 error. So you guys might be wondering why that 400. Well, if we look into the response, we see that this time the attribute is not allowed. So if we go back real quick, this on error is this source thing here that's just not allowed. So we're going to have to try and find a different one. So as you can see here in the solution as well, they tell you the same thing, just go to the clipboard. It's not allowed. You're going to do the same thing with the payloads themselves. So we're going to do that with the event in this case. And then we're going to go back here and we're just going to change the event instead of the the tag itself, but we have to remember to make it a body tag, otherwise it's not going to work, of course. So we're going to go back to our positions here, and this is not the one we need anymore, so we're just going to clear it, and we're going to replace this by the body tag. Now the body tag doesn't need a source, so I'm just going to remove it. Don't need it, remove it. And then the on error is going to be our specific one that we need in here. We're going to add this, then we're going to go to our payloads, we're going to clear this list, and we're going to paste the ones that we had before. We're going to start our tag again, and as you guys see, a lot of them will again return status code 400, but one of them will return status code 200, which means we get an OK back, and that would be the on resize. So that means that we need the body tag and we need the on resize event. So this does require some user interaction. So we do need the body tag in here, and we don't need that source anymore, so that can go. And we need the on resize event handler. So if we do that, if we resize the window, we get our pop-up, and that's how you exploit this. So that's how you solve the lab. But for this specific lab, we do need to do something else. Let's see, we did that. Okay, go to the exploit server and paste the following code, replacing your lab ID with the lab ID. So they basically want us to paste that exploit sheet. So we're going to do that. iframe source equals. So we're going to do an iframe. Let's see, on the exploit server, here we go, exploit, and then this body specifically, we need the iframe source equals, and then our specific, this URL here, this complete URL, I believe. Yep, there we go. And then want us to do, so we need to do that, and then we need to unload with. So this is basically going to set up an iframe on the exploit server. Let's see if we did this right. On exploit, no, we need a space in there. There we go. And then if we store this, we should view exploit. There we go, and that should solve our labs for us. So that's the lab for reflected cross-site scripting into HTML context with mode tags and attributes blocked. Pretty basic lab, not that hard to do. Hello, Mr. Secret Letters of a Hacker. Yeah, that's strange, you're not streaming on Twitter in 2021, right? Strange idea, I know. But I am the exception to the rule, you can say. So this one is reflected cross-site scripting, again with the HTML context with all tags blocked except custom ones. Now, you guys see HTML context here a lot, and that's really important to know because there's different contexts in cross-site scripting. This one is the HTML context, so we're going to look into that. And we're going to open the labs while that loads. Now, this is the specific solution. What they say here is pretty basic. If you ask me, they do explain it a little bit. But what this basically does is it allows only custom tags. And custom tags is basically, HTML does allow us to make custom tags. Like this one, this custom tag is XSS. But you can make any custom tag that you want, and you'll see that as well when we go over here. So they do allow custom tags, so we can type anything in here. And then we do need some attribute, some ID for example. And here we can, let me see real quick that I do have the right one. On focus equals alert, so we do need to ID equals on focus. And then the alert thingy in here. And then the tab index 3. What I'm just going to do is just going to quickly search for this. That's already going to fill in most of it. So we have an ID here, %3, and then I'm just going to copy paste it because I'm a lazy bastard. What are you going to do? Sue me? So this should be it, but it doesn't seem to be working, and I think it's because we are not on the exploit server. Let's see real quick, did we do anything wrong? So we have a custom tag. Let's try the custom tag cross-site scripting just to be sure. No results. And let's see where our cross-site scripting attack ended up in. Let's see if we can dissect it a little bit. So we do have our custom tag in here. It's not gone. It's in here, cross-site scripting ID equals X. But I see what we did here. We have two ID equals in here. That's not going to work. There we go. And then when we see that again, let's have a look, inspect element. And here we have the ID equals X on focus equals okay. So everything should be good in here. I think let's copy this then to the exploit server again. They want us to copy it in the exploit server in here, and you need to paste that iframe around it from the web security labs like this. Script location. So basically going to go to that specific folder equals and then slash script. Now is this correct? This should be correct. The anchor tag that's being used here, by the way, this anchor tag here is going to ensure that we scroll our page to this specific element and that we do put our focus on that element that we have made. So that's what this is going to do. You guys all know if I put an anchor tag in here in my URL, it's automatically going to scroll to there and going to put focus on it. So that's what that's going to do. You have your own focus event, which is going to pop your alert, of course, and then you have your cross-site scripting itself. You have a tab index of 1. This is going to ensure that if there are multiple instances of this tag on the page, that it's always going to come back to this one. So that's the basic idea of it. That's the basic gist of this specific exploit. We're going to store this. We're going to view exploit, and that should, in theory, pop up. But I think we made a mistake somewhere. %3. No, that should be okay. Tab index. I think I made a mistake in here somewhere. So let's just copy what they have fully, and then let's just replace our specific lab ID in there. Restore. Oh, right, of course. I didn't encapsulate it in single quotes. And I don't think this specific exploit seems to be working on the latest Firefox version. This does happen, and it's going to... It's pretty interesting. Sometimes cross-site scripting events just completely stop working when browsers update. And this might be one of those cases, because as you can see, I don't see any cross-site scripting pop-up coming up here. So I think maybe this is a case of Firefox being updated. Now, here we have reflected cross-site scripting with event handlers and href attributes blocked. This is a very interesting one because we do need to insert a click attack vector somewhere. Now, this is a pretty easy lab in the sense that all you have to do is you don't have to insert your literal link in here, but you have to encapsulate this link in an SVG file. So as you guys can see, they put an SVG in here. SVG, and SVG is basically an image file, but it's also an XML file, and the XML file describes what your image looks like. So that's what we have to do. We have to push all of this stuff into our SVG. We have to put attributes on there like this. So as you can see, we have an SVG with a thing in here, a link in here. We have an animate attribute name href, so that's going to put the href attribute onto the A, and then the value is going to be the JavaScript pop-up that we need. So, well, I'll say pretty simple. Of course, there's weeks, months of research after this, even more maybe, you never know. For us, it might seem a little bit easy to explain right now. It's pretty easy to explain, but if you're doing all of this research, it's not easy at all. And as you can see right now, it's created that SVG tag, it's created an A tag, and then an animate tag with an attribute name href. So the A tag is going to be animated by this specific thing with the attribute name href, and the value is going to be the JavaScript thing that popped up. And then we also put in a little text that says click me. the attacker can put anything in here that he wants, like click me for $1 million, click me for whatever, you know. So that's what that lab is all about, my friends. Let's see what the chat is saying, shall we? If you guys find this interesting or not. If you don't find this interesting, feel free to let me know. Let's see here. Alright, my friends, see you later, secret letters. If you guys have any questions about these labs or anything in particular, feel free to put them in the chat. I will happily answer them for you. Now this is reflected cross-site scripting with some SVG markup allowed. Now in this particular lab, it's a simple reflected cross-site scripting, they say, but of course it's not very simple at all. The site is blocking common tags but misses some SVG tags and events. So we need to perform a cross-site scripting attack with the SVG attack vector. Now the basic attack vector is not going to work in here basically because they are blocking it. They are blocking a lot of tags and we're going to do the same technique as we did before basically, where we try to brute force the page with the specific tags, and we're going to try the same thing here. The only difference is we're going to find out that the SVG tag is going to be the one that's allowed in here, and the SVG tag is going to be like, let me quickly open that here. SVG tag is something that you can put animation, transformations, and titles, images. So basically, if we put this SVG in here and we put it like this, SVG with an animate transform on begin equals alert, so that's basically an SVG that's going to try to animate itself, and when it does that, it's going to pop an alert. So basic things, really easy to be honest, and not something like this one is pretty easy in the sense that it's not hard to find, but it's hard to perfect, because all of these things in here that you see, knowing that an SVG is basically an image with an XML file and that nothing in that XML gets properly checked by most scanners, those are some techniques that you have to know. So that's a summary of what we've learned so far, is that SVG seems to be really good at evading scanners. Maybe we have to look into that some more instead of always using the image tag. Could be an option. Maybe SVG is filtered more than an image tag. Who knows? So to solve this particular lab, pretty simple again. All you have to do is put this here, search. There we go. And you don't see an animation in here, of course, because there's nothing in here, to be honest. Now, if I look at the context that this is reflected in, you do have some special elements here. Because as you can see, it's pretty much this SVG is in here, but you also have this in here. And if we remove this less than sign and this double quote, it still works. Okay, my bad. I thought it wasn't gonna work, but it works apparently, so we don't really need them in there, at least not in Firefox. Now we have that's already done. On to the next one I said. There we go, reflected cross-site scripting into attribute with angle bracket HTML encoded. So this is a pretty interesting one basically. Let's access the lab. So this is, they're telling you how you should always test for cross-site scripting if you want to actively hunt for it. They're saying you need to submit a random alphanumerical string in a search box, then use burp suite to intercept the search request and send it to the repeater. So what they're doing with this alphanumeric string is they're testing for any reflected values on the page, as you can see in here. Now they talk about doing it in the burp repeater. That's possible, of course, and that's going to be the easiest way as well. So I can search any reflected value in here, and then I can copy that value and I can go into the burp suite proxy and I can go into my history here, and then I can easily just look into the response as well, and I can see that my value is reflected in here. But if I look on the page itself, it's also pretty obvious. It's reflected in here and reflected in here. Now, it's not always going to be this obvious, of course. Sometimes you're going to have to search a lot harder, and it's going to be in the JavaScript context instead of these contexts. So let's try and break out of this, shall we? This is, let's see, inspect element. Now, if we look at this specifically, we see that it's reflected into the value attribute of the HTML tag. If I try to do something else in here, like for example, let's say if I try to insert the image tag in here like I always do, and I search for it, then let's see what happens. So in the value, it's being reflected basically like it's supposed to be in here. We see the value being reflected properly, and we see the value in here being reflected properly as well into the H1. So we don't have what we need for cross-site scripting in here. But since the value is reflected in here in the value attribute, what we can do is try to break out of that attribute specifically, and then we can also do our own tags. Image source equals x on error equals alert, and let's see if this works. This doesn't seem to work. Now if we look at this specific tag, inspect element, we see that some strange values have been encoded here. You can see that the less than and the greater than sign have been encoded, basically bracket signs. That's not a huge deal, because since we are in the input element here, what we can do is we can use that double quote to break out of the element, because as you can see, value is basically broken here. There's nothing in value. Then there's some custom attributes in here, source equals x on error equals alert, all of this stuff. That's not really that important to us. This is an input field, so we can, for example, on mouse over, this is a JavaScript event, we can pop an alert on mouse over, and then we can end just to be sure, and bam, that's how we get our cross-site scripting in this one. So the on mouse over here, they use the extra double quote here. I don't know why specifically that is, but that's how I do it for my end. Now on to the next one. We have this one, stored cross-site scripting into anchor href attribute with double quote HTML encoded. So now the double quotes will be HTML encoded, and we might have to find some other solutions. Hey Uvio, yes, live. We are doing some live hacking for you guys. I hope you guys are enjoying. If you guys have any feedback, feel free to let me know in the comments or in the chat, of course. Now let's see. In here, they're going to do the same thing. They're going to say something is blocked in here, find out what it is. And in this case, they're going to basically try to get us to insert a URL. So for this lab, we need to find a stored cross-site scripting vulnerability in the comments functionality. So let's have a look, shall we? Let's view these posts. And here we can leave a comment. Apparently we can leave a comment, a name, an email, and a website. So let's do that specifically. Let's just put some mumbo jumbo in here, and for email it's going to complain, so we're just going to put the thexssrat@gmail.com, and let's check out what it gave us. So back to that specific one. Let's refresh it, and here we go. We have our comment. Now we have a name, a URL in here that seems to be going to that value that I entered in here. So the website is linked to that value. That's good to know. And our random alphanumerical chunk basically got in here, and you see the href, that's this value, and this is the name. So since the href is being reflected again into this here, well, that might mean that we can do the same trick as before. So we might be able to do a double quote. We might be able to do our on mouse over or something like that, or on mouse over equals alert, and try and see if that pops. So we have our comment again, and we need to refresh the page. And this comment, it doesn't seem to work like we want it to work. So that's not good. We need to find another way to solve this apparently, because that doesn't seem to want to work. If I click here, if I look at this specific element, you guys can see that the element is not escaped like it's supposed to be. You guys can see that in here it's not properly escaped. That's not going to work. It's not a mouse over event apparently. So what they basically tell you to do in here, what you have to do in here is you basically have to, let's enter our email address again. You just have to do the JavaScript directive. What a directive is when I add this to the URL JavaScript alert. What this is going to do is it's also going to pop up an alert box. So let's go back to our comments again. Go back to that last comment, and there we go. We also have a pop-up here, and that's how you solve this specific labs. Hey guys, so many of you here. Nice to see you. I hope you're doing well. Thanks for the compliments on the overlay. That's Uvio's work. So if you guys want any of that, feel free to contact him. This is all gone, and then we look onto the next one, reflected cross-site scripting into a canonical link tag. This is also a pretty interesting, I love this one basically. So you have to solve this in Chrome, so I'm not going to completely solve it in here, but I will take you guys through the solution because I think this is brilliant. Now what we have here is you have the same thing going on as you normally would, but what this thing is going to do is this is also reflected, and it's basically going to reflect this value. So this sets the x as an access key. What they're talking about is access key equals x and on click equals alert. So what they want you to do is click on a specific thing on the page. This is going to be reflected into the canonical link. So that means that whenever we press that button X, that means that it's going to pop our exploit. Now, this is a pretty far-fetched one, so you don't have to worry too much about this one. This one is not going to help you in the wild. This one is far too far-fetched for that, and it's going to be like, yeah, that's going to be way too many actions for an exploiter to actually do, so not valid. Don't even bother with this one unless you're actually really interested in it. That's really like, it's a really cool laboratory, but it's not going to help us that much. Now for this specific laboratory, this is going to be the reflected cross-site scripting into a JavaScript string with single quote and a backslash escaped. This is a really interesting one. So if I go through this one, you guys will see that my value is reflected into the JavaScript context, which is totally different than what we've seen up to this point, because up to this point we've been talking about nothing but HTML injections. Now we're actually going to try and see what a real JavaScript context injection looks like. So this is basically being reflected onto the page, but if I look into Burp Suite properly, I need this specific value, and this one needed from Burp. Where are you? So you can see that it's reflected on several places here. 0 search results for, that's what we're already used to, but then we also have this variable search terms where it's reflected into, and it's not escaped, so that seems to be a dangerous combination. What we can do here is we can enter a single quote. We can just do this to end our JavaScript statement, and then we can pop an alert. It's as simple as that. Maybe you can end the alert as well, put everything else in comments. It should be as simple as that, but apparently I forgot something very basic. Try sending test payload, yes. You just escaped from the script. But that shouldn't be too bad. I'm going to see real quick, because this is something I want to know what went wrong. Let's inspect the element here. 0 search results for, but they also have this script here, and this seems to be broken completely. It's just, yeah, something seems to be messed up. So let's try again, shall we? A single quote, and then I end my declaration of my variable, and I pop my alert, and the rest is just able to execute, I guess. Oh, because right. I see what the problem is, because this single quote is opening JavaScript, I think, and it's never closing it. Am I right? No, I don't seem to be correct in this one. So I don't know why it's not popping, but this is basically how I would look for my testing. To break out of the script block and insert a new script. Because I'm completely out of the block. Is that true? So let's try that. If I get completely out of the script box, it does seem to be popping my alert. That's really strange. I'll have to look into this because this is something I find interesting. So what they did is basically the same as me. They entered a single quote and then they entered the alert. What they did was they entered a script tag, and mine is not working, and theirs is. So I'm a little bit confused. I'll have to look into this. I'll be sure to let you know why this happens on Twitter. But anyway, that's how you basically solve this. On to the next one, we have reflected cross-site scripting into a JavaScript string with angle bracket HTML encoded. So this is the same thing that they wanted you to do as before, but only this time you're not going to be able to insert a new script, a tag vector, a new script a script tag, I mean, of course. So they want to just basically insert the JavaScript itself. Now in this technique they used a single quote like I just used to break out of the JavaScript, and then I think this is a comment, but I'm not sure. And then if you guys are familiar with JavaScript, please feel free to let me know, but I think this is something to comment out some stuff. And then they pop their alert, and then they break into their... Let's just see what happens when we pop this in here. So let's open up the element, the inspect element thingy in here, and here we should see another script. In here you can see the lab header, main container. Here we should see a script, and here our value is being reflected into, so it should be possible for the other one to be popped as well. I'm sorry, I don't like letting go things, so let's try and pop this one as we popped it before. This one also doesn't seem to pop, so something seems to be different in here. Now I need to investigate, but it's interesting to me, very interesting. On to the next one, ladies and gentlemen. We have reflected cross-site scripting into a JavaScript string with angle brackets and double quotes HTML encoded and a single quote escaped. So this is they call this a practitioner lab, but this is pretty much interesting for if you really want to test for it really like a lot, because in this lab what they're basically going to do is that this is escaped. Basically the double quote is going to be escaped. It's messed up. So what we're going to do is we're going to send up a backslash, and that backslash doesn't get escaped in here. Then that backslash basically allows us to get through. So what they do is they try to insert the alert by inserting that backslash, and then they do their single quote, which is going to mean that it's not escaped, and then you can insert your alert attack factor. So if you want to solve this lab, it's pretty simple. You just have to copy this attack string. But if you really want to solve it, really want to know what's going on, we'll look at that as well, just to make sure that you guys understand exactly what is going on. So what we do is, if we have a double quote, it's going to not work. If we have a single quote, it's not going to really work. It's not going to break out of any JavaScript contexts. It's basically escaped in this case, as you guys can see. But when you do the backslash, we notice that it's not escaped. So that means that this backslash, and you guys will notice, by the way, if you look in the JavaScript code itself, and here in the script tag, we will see that if we do a double quote, and of course it's going to lose it again, it's not going to work. Name search, there's no value in here. So if we do like this, just to make sure that we do see a value, or should say a value, you guys can see that there is no value. It's basically being filtered out. But if we do pop our alert like this, it is going to pop up. There we go. And we can see that as well in the script tag here. So really cool, really interesting laboratory. On to the next one, I would say, which would be reflected cross-site scripting in a JavaScript URL with some characters blocked. This is an expert lab because you're going to have to do quite a lot of work to get through for this one. And what this one is basically going to do is Oh nice, they added some explanations, so let's read them. The exploit uses exception handling to call the alert function with arguments. So what it's basically going to do is it's going to throw a new alert, throw on error, and it's going to throw the alert button, the alert function. And then of course, as we throw that error, it's going to try and circumvent certain filters. It's basically going to try to get around them. So a throw statement that cannot be used as an expression, so you need to use that throw statement to create a block so that the throw statement can be used. So that means that by block they mean this thing, so we start basically a new block here, and then we throw the alert, and then we enter a block. This is what they mean by a block, these squirrely brackets, because it's in JavaScript code basically how you define that. What else do we need to know? We then need to call this function, so we assign it to the toString property of the window and trigger this by forcing a string conversion on window. So basically a lot of mumbo jumbo. What all of this is together is that we basically assign a variable toString here. toString is going to be the window variable here, and that toString variable is going to contain what we need in here, and then we're basically going to force a variable toString, and it's basically going to force that alert to pop up. So quite a lot of things you have to do in here. We need to get to the post ID specifically, so we need to open a post, doesn't really matter. I'm gonna need to paste this behind here. And it's not working on Firefox, that's typical. Now this can happen, like I said, sometimes it just doesn't work on specific browsers. It might be that I open this in Chrome now, and it might work. Well, apparently it did work. So the reason we're not seeing it pop up is because we're not forcing anything to string, I think. But sometimes it works in some browsers, sometimes it doesn't. Now I'm going to skip quite a few for you guys, and I'm going to go to this because this is something I want to show you guys. This is a lab that I really like that I haven't solved yet. So what this lab is it's going to try to break out of AngularJS, because this lab specifically uses AngularJS in an unusual way where the eval function is not available and you're unable to use any strings in AngularJS. So the eval function in this case is not available. Now, researchers have found several ways to break out of AngularJS to sandbox mode. If we talk about AngularJS, what we're basically talking about is a front-end technology. And AngularJS is going to sandbox everything that you throw at it. Now that also means that whatever we throw an expression at it, AngularJS is going to try and evaluate that expression, see if it's safe, and if it's safe, it will evaluate it. It'll basically watch for words like JavaScript terms like alert and all of that stuff coming up into your search term. And that's basically how the AngularJS sandbox works. Now what we're going to do today is we're going to break out of it by using the toString function. Again, this toString function here. And it's going to get the string prototype and override the char_add function. So we're basically going to override this specific function here. That's important to know. We're going to use the toString function, and we're again going to use this order by that I think we've seen before, but I'm not sure. If not, we'll talk about it. So next, an array is passed to that order by filter. So this specific filter is going to get assigned an array here, this specific array here, and this array is going to say from character code make a constructor, put that to string, and order that put that in the order by variable. Now what it's going to do is it's going to override that char_add function here, which is going to mean that this character add is going to compare a single character to an array of characters. Now the way that specific function is built up is that it's always going to return true if this happens. That's bad because this is the comparer that checks if your JavaScript is valid or not. and if it's always returning true, it's going to accept any input. So that also means that we can insert our own text string in here, and that a text string is going to be x equals alert, and that x equals alert is going to be converted into characters. That's this one, 120 is x, this is equals, and then you have all of these characters. This is the basic ASCII table. So because the character add function has been overwritten, AngularJS will allow this code where normally it would not. So basically what we do is we just visit this web page. Let's see here. Oh, we haven't accessed it yet. So let's open those labs while we open the next one and have a look at that as well. This is going to be a very similar solution, but in here they try to bypass the CSP. Now, content security policy is not going to be easy to bypass, especially because we're already working with AngularJS in this specific instance. But to use this exploit, what they did is they used the ngFocus event. And that specific event in AngularJS is going to focus on our specific item that we have in there, which is going to allow us to bypass that CSP, because the ngFocus is basically it's not checked properly by CSP, and of course that is not good. Then we're also going to use the event, which is in AngularJS variable. This event references specifically sorry, I kind of lost what I was going to say there, but it does not really matter. And then we have a path property that's specific to Chrome. If we look at that right here, or was it right here? So this path element, what this is going to do is it's going to contain an array of elements that triggered this specific event, and then the last element in this array is going to contain a window object. So then we also have this this pipe symbol here that you see in JavaScript. That would normally be a bitwise operator where it would compare several bits with each other, but in AngularJS this actually means a filter operation. So that also means that in this case the order by filter here, this one specifically, is going to be called by this. And then the colon signifies an argument, so this one signifies that an argument is being sent to the filter. This means that this argument is being passed into the filter, indicated by this, and the filter itself is indicated by the pipeline. And we're basically going to try to circumvent all of our security by executing the ngFocus event, which is not properly checked by CSP. Are you guys still with me on this one? That was not an easy one, but we got through it anyway. Hello, Mr. Lemons, how are you doing? Hello, Mr. Tazra as well. Oh, it's my pleasure to give you guys my time. I love streaming like this. So for this lab, it's pretty easy. Again, we just copy this and we paste it in any search term that we have, so it doesn't really matter. There we go. And we have our labs solved. Now, as you can see, this doesn't work in Firefox. AngularJS is heavily sensitive to the browser that you're using. Very heavily sensitive. So if it doesn't work, try checking another browser. And that's the thing with cross-site scripting as well. A lot of people think that cross-site scripting will work the same on every single browser, but that's just not the case, because cross-site scripting is just designed in so many different ways as well. And cross-site scripting, it never, like, it only occurs because the browser creators interpret the RFCs differently. So that means that all of the different exploits can act differently on all of the different browsers. It's just that simple. As like this one, for example, it doesn't seem to be loading my results properly. It did create an input box for HTML injection, but it doesn't seem to work properly on Firefox itself. So it really depends, you know. you first of all have to be a little bit lucky to find all of those cross-site scripting and tags, but you also need to have the right browser, have the right mentality, have the right mindset, know how all of this stuff works. It's not easy, you guys. So those were a couple of cross-site scripting events. Let's talk a little bit about CSRF, shall we? Cross-site request forgery. I'm going to do a few more labs on CSRF and then I'm going to call it a night. But let's do some for these, shall we? So CSRF on this one is pretty easy. This is the first basic CSRF attack in the game, and it's very, very easy. So what you really have to do is you have to have Burp Suite open, of course. You have to have some patience to start up the lab, and you have to know that the account is Wiener Peter in this case. So what you want us to do is basically exploit this CSRF attack, if it will allow us to do that, by changing the email address of that person here. So this person is not logged in at the moment. Let's do that, Wiener Peter, and you guys can see that I can change my email address. So let's try that, test@gmail.com. Let's update my email address, and now if I go and look into Burp Suite here, if I do my post in here, I do see some no CSRF token at all. So that means that this request is highly susceptible to CSRF attacks. I can demonstrate that by right clicking in here, and in here I can click engagement tools and I can generate a CSRF proof of concept. Now this proof of concept I can then test in my browser like this. I'm going to close it for a second because what I really want to do is go and change it to something I haven't changed it to before, like this one. Then I'm going to do the same thing, like generate my CSRF POC. I'm going to test this in browser, which will give me a URL. It will copy that URL. I will paste it in here, submit my request, and then I have my CSRF attack done. Now if I go to my account, as you can see, it has that new email address in here by executing the CSRF attack. So that's a basic CSRF attack. There's nothing in here, no CSRF tokens. It might happen. Let's go to the next CSRF lab. So we might, let's see, this one is good. I like this one, so we'll solve this one, or at least we'll try to. This specific one is when you make a post request, it's not specifically vulnerable, but when you make a get request, it suddenly becomes vulnerable to CSRF attacks. So it does sometimes matter what method you use. So let's see here, Wiener Peter was login. Let's log in as my guy here, and let's go test@gmail.com again. Let's update the email address, and if we do that, we go back to the proxy. We see here post to email address. We do see a CSRF token now. So what I would do is, if I were you, I would play around a little bit with that CSRF token, see if it might accept like something like this, or just maybe something like a 1, for example. Let's send that over, bad request, so it's not going to take that as a CSRF token. Maybe an empty CSRF token, no, also not available. So we need the proper CSRF token, it seems. And I say it seems because if I right click and I click change request method, and then I post, it doesn't give a crap anymore about that CSRF token. As you guys can see, it changed my email address completely. So sometimes, that's just what I wanted to show you, sometimes the CSRF token being checked depends on the method being used. For example, you have put and post as well, so you might be able to play with those a little bit. Hello, amazing hacker. I hope you're doing well, Mr. Osan. Alright, let's do some more labs for a finale. Let's make it a home run. This specific lab is going to check if the token is being present. So if you open this lab and have a lot of patience, you can see that this just checks if the token is present. Doesn't really matter what the value is in it, or at least I think that was the one for this one. Delete the CSRF token. Okay, so it doesn't even check if the okay, yeah, I know what this lab is. So this lab is a CSRF misconfiguration where the token will only be checked if if the token is set. If no token is set at all, then it's not even gonna check the token. And that actually does happen in real life. That's why I have so many methods of checking for CSRF tokens basically. So I think I'm going to leave it at that. One thing that might be interesting as well is if the CSRF token is not tied to the user session, then I can request a CSRF token and still perform a CSRF attack on your name, because I do have a CSRF token on my name. Now, on to the CSRF where the refer validation depends on header being present. This is also just a validation where if the header is not present, it's just not going to check that CSRF value. So you have to make sure that you include this specific HTML tag into your POC, into your proof of concept, because if this one is present, then the CSRF value is not going to be checked in this instance. This is basically like, how do I put this? Well, it basically depends if this tag is being set, a header is going to be set as well. And if that header is present, then the CSRF token is not being set. This sometimes happens because you might have some programs that do require you to actually go and, for example, if you have a change email address and you have a third-party option to change that email address, then they might make a CSRF request from their own server to your servers to change the email address and name of somebody else. But that's basically something you never want to do as a programmer. It's a very, very bad idea. But still, some programmers do it, and this is of course the result. CSRF vulnerabilities everywhere. So don't go with bad practices. That's basically what I wanted to say for that. That's all for now. Thank you guys very, very much for watching. I hope you enjoyed this magnificent stream on this magnificent day with this magnificent Mr. Rat. I hope you enjoyed amazing rats. Yes, sir. Amazing rats. I will see you